A faltering photonics company sells its assets back to its founders. China suspends export restrictions on industry-critical rare earths and minerals. And can a universal coupler make building quantum computers $900 million cheaper? All your industry headlines and more are on Photonic Spectra now. Photonic Spectra Now is brought to you by Edmund Optics. The future depends on optics. Visit edmundoptics.com to learn more. This is Photonic Spectra Now, covering all the latest news and developments across the industry. I'm Joe Kaczynski, Senior Editor with Photonic Spectra. A sign that a trade truce between the world's biggest economies could be holding, China is rolling back restrictions to the US on its exports of rare earth materials and critical minerals. Recent trade controls targeting materials vital in photonic applications and restrictions dating back to December of 2024 designed to curb the trade of gallium, germanium, and antimony will be on hold for 1 year. The latest of those restrictions from China was announced last month as a response to rising tariffs from the White House. Trade talks between the nations may be improving now as the US has agreed to lower tariffs on Chinese imports by 10 percentage points, suspend what the White House called reciprocal tariffs, and postpone a motion to blacklist majority-owned subsidiaries of Chinese companies. Staying in the States, the US Department of Energy is investing hundreds of millions of dollars to advance the next phase for National Quantum Information Science Research Centers. $625 million will go towards research centers with Brookhaven National Laboratory, Fermi National Accelerator Laboratory, Argonne National Laboratory, Lawrence Berkeley National Laboratory, and Oak Ridge National Laboratory. Each lab has its own focus on advancing quantum systems. You can learn more about their specific missions on photonics.com. We have an update for you on a photonics company that had entered into administration earlier this year. M2 Lasers has completed the sale of its assets, with that intellectual property returning to the company's founder. Let's explain. Joint administrators reviewed several offers before selecting Novacine Photonics Limited as the preferred bidder. Graham Malcolm and Nils Hempler serve as directors for Novacine. They also served, respectively, as CEO and COO of M2 Lasers. Back in August, M2 halted all trading, entered into administration, and laid off 28 employees after revealing details of its debt. Officials with Novacine say they are excited to build on M2's legacy in photonics. Lots to cover in the world of mergers and acquisitions. First, Wasatch Photonics has been acquired by FOSS Group, a Danish provider of analytical solutions. For roughly $39 million, FOSS Group will add Wasatch spectrometers, gratings, and solutions to its own portfolio, expanding its market reach for groups operating in Raman spectroscopy, OCT, astronomy, and laser pulse compression. This latest acquisition from FOSS marks its fourth investment in a photonics company. Those will be gathered under the name FOSS Photonics. EMTEK Holdings has acquired Qbert, a developer of snapshot hyperspectral cameras and analysis software. The new partnership, with EMTEK taking the majority stake in Qbert, will aim to scale the imaging company's tech globally, reduce development cycles, and speed up commercialization. Qbert will serve as the foundation of the newly formed EMTEK Hyperspectral Group. Coming soon to the NASDAQ and Toronto Stock Exchange, Canadian photonic computing company Xanadu Quantum Technologies has announced plans to go public. The company will debut on the market through a merger agreement with Crane Harbor Acquisition Corp. Xanadu's photonic quantum systems compute at room temperature and feature modular, scalable architectures. The deal valued Xanadu at a pre-money equity value of $3 billion. In R&D news, a newly developed universal coupler could reduce the cost to build a quantum computer by $900 million. Quantum Pulse Ventures, a company focused on removing barriers to quantum computing, says their device can dramatically cut costs to a build by lowering hardware requirements, reducing runtime, and improving robustness against imperfections. Working with a research team at Tel Aviv University, QPV created a universal directional coupler that leverages the same principles that allowed the first MRI machines to enter the integrated optical domain. Compositing pulses reduces error rates, thereby significantly reducing the number of qubits needed, and reducing financial costs substantially by cutting back on manufacturing, cooling, and networking requirements. Researchers at Columbia University have made a dual-function discovery in integrated photonics. They found that the thin-film metallic resistor, routinely used to thermally tune photonic devices to the desired resonance frequency, can also measure temperature. This finding could eliminate the need for bulky and costly external temperature sensors. Joining electrical and photonic circuits has long been the goal of integrated photonics, but electrical circuits are notorious for generating heat and those photonic circuits don't always react well to that. These thin film resistors can act as an on-the-chip thermometer, helping users mitigate thermal variations that can be problematic for photonic devices. Researchers hope this finding can bring us another step closer to realizing large-scale photonic devices capable of operating in real-world environments with varying temperatures. Have a story tip? You can email that directly to me at video@photonics.com. And for more details on these stories, be sure to head to photonics.com. Before you go, give us a like and be sure to subscribe to the Photonics Media channel on YouTube for the latest from PSN and the All Things Photonics podcast. I'm Joe Kaczynski, and thanks for watching.